In this entire system of billions and trillions of stars, our sun is the only source of light. Not only light, our whole system relies on it. Food, that is a basic requirement, is prepared by the primary producers, plants, by using the sunlight energy. And this food is eaten by various consumers in the food chain. Sun drives the weather on Earth as well. Temperature differences create variable pressures, driving the movement of air that is associated with the variable weather from equator to polar regions. From fresh water to fresh food, sun nourishes to all of us. But there will be a time when the supply from the sun will stop and our planet will turn into a dead corpse. Like our body needs fuel, sun also requires fuel to grow. Its fuel is produced in its core, but the fuel won't last for long and a star suffers a death. Then what about our Earth? And what is the point of even shifting to Mars when our hosting star will die? Let's find out the fate of our sun and its planets. All the stars has a core, the place of fusion reaction. It is enveloped by outer layers, photosphere, chromosphere and corona. Each star undergoes the same fate of birth, growth and death, and this process is called life cycle of the star. This begins with the first stage as the birth of star from the clouds of gases. This cloud is composed of hydrogen and helium gases. In the second stage, cloud transforms to protostars when the gas particles starts moving towards each other and produces heat to warm up the gas molecules, and this warm clump of molecule is called protostar. Next comes the T-tauri stage. This begins as material stops to form protostars. Huge amount of energy is released at this point, yet this energy is insufficient for nuclear fusion reactions to fuel up the star. And in the meantime, protostar becomes incrementally hot and fourth stage arrives known as the main sequence. Here, the protostar converts to star as soon as the nuclear fusion reactions begins, where hydrogen proton converts into helium and releases huge amount of energy. Note a point here that our sun is currently at this stage of main sequence from the last 4 billion years. Currently 600 million tons of matter is converting into neutrons and radiations. Every second 4 into 10 raised to the power 27 watts of energy is releasing. So far, sun has fused hydrogen equals to 200 times the mass of the Earth into helium. Increase in fusion increases the activity of the sun. So every 100 million years, there is 1% increase in its luminosity. From its birth, sun has suffered 30% increase in its brightness. In the next 1 billion years, it will increase to 40%. As yet, we have discussed the 4 stages in the life cycle of star. Also learned that the sun is currently in the main sequence stage where hydrogen is converting into helium atom. Now coming to the 5th stage that arrives when all the hydrogen runs out and fusion reaction ceases. This leads to instability in the core due to the loss of fuel, and this phenomena contracts the core of the star and expands the outer layers. Expansion causes the cooling and changes in the color from yellow to orange to the red, and ultimately what we get is a red giant star at this 5th stage. Our sun will undergo this red giant stage in the next 4 to 5 billion years, where the expansion will stretch it beyond Mercury and Venus, causing 1 AU to 2 AU swell in its radius. Both the planets will be eaten up by the red giant sun, and our Earth might be eaten as well. Or even if it escapes, it would be deadly close to it. Earth may escape its grasp, but its extreme heat will boil our oceans and atmospheres, and no water means no life. Our planet would turn into a new Venus. So far, we have learned how in the 5th stage, hydrogen fuel loss will turn our sun into a red giant star in the next 4 to 5 billion years. From the 6th stage, a star follows a different path of evolution depending upon the mass of the star. The universe has variable sizes of stars. Our sun is a medium-sized star, but there are massive stars that are 3 to 4 times larger than our mighty sun. And these massive stars again start forming new elements by fusing helium into carbon, oxygen, neon and finally iron in that contracted core after becoming the red giant. As iron is a highly stable element, hence it will not further fuse or undergo any changes in its stable state. Therefore, these massive stars stop its activity and suffers a gravitational collapse, where all the iron is crushed up. At this moment, temperature decreases to 200 degrees Celsius and builds up the repulsive forces that will explode the star outwards in the most violent manner, and this is how a star goes a supernova. The remnant portion after the supernova is known as a neutron star, and if it's heavy enough, it will again collapse under the gravity to form the black hole. Thus far, you have got the idea how a massive star dies. Now coming to the medium-sized stars like our Sun, which are not massive, hence do not explode as supernova as they do not have the required mass and energy. So our Sun, after expanding as red giant and extending closer to Earth in the fifth stage, it will lose much of its mass through stellar winds and will push the orbits of the planets away as its gravitational field will also expand. So it's a doubtful scenario if Sun will grasp Earth or throw it away from the location it is currently lying. Also, there is a habitable zone, that is an area around a star where the temperature is not too hot or too cold for water to exist as a liquid state. And this zone will also extend beyond Pluto as heat from the Sun will melt the current icy planets. The moon of the farthest planets like Neptune and Pluto will develop the tropical temperatures similar to here on Earth today, and this will bring the possibilities for life to generate there at that point of time. Our Sun will continue for 1 billion years in this red giant phase and won't stop there. It will still have 120 million years of life left. And in the next phase, the contracted core of the red giant will start a new fusion reaction from helium to carbon, and ultimately core will run out of helium fuel also. This loss of fuel and energy will dominate the work of gravitational forces, and the red giant star will again contract. And it will shed its outer gaseous layers as planetary nebula. Contraction brings electrons closer to each other, but this is against the law of quantum mechanics. Hence, it will lead to a situation known as electron degeneracy. This means no two electrons can occupy the same energy state in the same atom at same volume or space. So when all the lower energy states are filled, electrons start moving to achieve higher energy state. The movement of electron creates a pressure known as electron degeneracy pressure that will hold a star from further collapsing and will transform our Sun into a white dwarf star that will equal to the size of our Earth. And it will continue its life for more than a quadrillion years, and in the meantime it will lose all of its heat and will turn into what is known as black dwarf star. And this is how Sun will die, taking away all the lights from the planets. The fate of the Sun and the planet will be an abrupt journey that will lead to the death of the whole system which existed for more than 10 billion years. I hope this presentation has given you the idea about the life cycle of our Sun and the massive stars. Check more videos popping on your screen right now related to Earth, oceans and space sciences. I'll see you soon with another new video. Till then, goodbye.